talk is about the technological transition from hydrocarbon to mining. And when we talk about hydrocarbon, we talk about the kingdom with such long heritage of hydrocarbon industry for the last 70 years. And the big question, what we consider to be the million-dollar question, how we leverage our understanding of hydrocarbon industry in terms of the science, in terms of technologies, in terms as well of the mindset, how we explore hydrocarbon reservoirs for the mining industry. Today, along with my colleague, Saad Al-Malki, we started with the motivation. The companies that you see in front of you, I'm not sure how can you, okay. The companies that you see in front of you, some of them, they experienced transition from hydrocarbon industry to mining industry, and the reason behind it, because of the lithium extraction from reservoirs, from the brine. And that's very clear. But that's not my point here. My point for the companies that really experience the transition from hydrocarbon to mining based on the mining technologies and the technologies that have been developed for hydrocarbon so far. So when we try to map those technologies that have been used for hydrocarbon, we start, for example, with the geophysics. One of the geophysical technologies that have been introduced to hydrocarbons is seismic, very known for hydrocarbon, that's been, experienced a transition to the mining industry. Not so recent, it's been a while, but there are a couple of challenges around. When you talk about geochemistry, it's a very known technology that, been experienced in hydrocarbon for a long period of time. Geological interpretations, modeling and simulation, geostatistics, well logs, and core sample analysis, along with the remote operation. I will go over all of them and focus on the simulation and modeling for the rest of the talk. So starting, for example, geological interpretations. The geological interpretations that have been developed for a long period of time with the hydrocarbon and been introduced in the mining industry very effectively for the last few years. And the importance of this, how to manipulate the distance between different wells to know the existence of the subsurface or deposits. When we talk, for example, about the petroleum exploration, seismic exploration for petroleum, and we compare it to the usage of seismic in equal industries like the mining, we see the shortage very large. But we today, in the future technology hubs, we think how can we leverage the technology development and research and development centers of excellence to ease that transition and fill the gap and tackle the given challenges that we face using seismic exploration or technologies for the mining industries. And that is one of them. We'll talk about the geochemistry as well. The focus on organic compounds and sediments that's been for a long period of time in hydrocarbon. And the transition of using the same mindsets of geochemistry to the hydrocarbon is very important, especially for the hydrothermal deposits. I'm moving very fast because the main talk will start in 4 slides. The geostatistics as well, the reservoir characterization, the seismic data integrations, the phases modeling, well placements, all of them being used for a long period of time in hydrocarbon. What about the mining industry? Ask this to be a trend of using geostatistical tools for mining explorations in general. And well logs as well, very known in hydrocarbon, and it's been used for a long period of time in the mining industry. However, it is not the main tools for mining industry. And it can be transferable in terms of technologies in much details in the future. The most important thing is the remote operations. If any one of you visits Saudi Aramco, they have what they call in Saudi Aramco, I think, the geosteering operation center. The interesting about geosteering that you are in Dhahran and you can control the well in Shayba, which is 500 kilometers from Dhahran. You control the well in northern border, which is 1,000 kilometers from Dhahran. And within one single center, you can control all the wells and increase the productivity of oil. If we try to compare that technology usage In the mining, we see Rio Tinto. They have similar center in Australia. However, it is quite new for a couple of years now. But what is the underlying piece of information that enables Saudi Aramco to go this mile? That piece of information is the modeling. Modeling the reservoir and the position that you can control the drill away 1,000 kilometers is the real challenge that we face today in the mining industry. The mining industry, if we, for example, talk about the reservoirs, they are mostly in sedimentary rocks. And your constraints from sedimentary rocks comes from seismic. However, in the mining industry, there is most of our constraints coming from igneous rocks. And the change in velocities in terms of seismicity and seismic explorations does not really give you precise boundaries between the given ore body and the surrounding or the host rock. And that is a big challenge for us in the mining industry. And that's why from here, we think about if we bring our scientific mindset to understand different layers in Earth, as investigators, we have to consider the modeling. However, the modeling is interdisciplinary approach, interdisciplinary field. It is not that simple like data acquisitions. We usually, in the modeling world, start from model, end by data, and that's what we call predictive models. Or, in the other side, we start from data and end by models, and that's what we call inversion models. All of that will be in the basis of given indicators that should exist with us, starting from structural indicators, exhumation rates, geophysical data sets, hydrothermal indicators, geochemical constraints, as well as tomographic models for the regional trends of mining sets. So when we talk about the modeling, we have two parts. The first part, what we call the inversion models. With the inversion models, we start with the data sets. We try to convert the data constraints into characteristics for the subsurface, physical characteristics that can be interpreted as mineral deposits. And with this, we use the known equation from model to data using the green function. We get the inverse to get the model based on the data constraints. With this work, we have the privilege at KAXT to lead the project in 2016, and that project to explore one of the areas of interest in Western Arabia, which is the Harrat Rahat. When we call Harrat, we mean volcanic fields. And the interesting thing about this volcanic field in Western Arabia, to the vicinity of the volcanic field is Mahd al-Dhahab. It's the largest gold mine in the kingdom. It's been around for 3,000 years, since Solomon, prophet, peace be upon him. And the interesting about this, you can see an extension of potential mineralizations under the cover of the lava. However, you don't have any access to it. There is no surface exposures. And that was the driver for doing the work that adopted by King Abdulaziz City for science and technology. We brought airborne geophysical data surveys for magnetic, gravity, and electromag. We conducted that survey for 100 kilometers length profiles with about 70 kilometers length profiles. And by the end of the day, we got anomalies, a couple of anomalies, about 8. Some of them for hydrothermals, geothermals, and some of them for mining, for gold. We drilled through one of them, 2 drills, up to 300 meters, and we got the constraints published. We got gold. The idea behind all of this success story is not about gold. It's about the mindset that's been adopted from hydrocarbon industry for the mining industry for our benefits. And with this work, in fact, I'm proud that we lead a project in collaboration with Ma'aden, in collaboration with Ivanhoe and CGI. It will be announced in 2 days from now as a joint lab for developing inversion models within KAXT for the technology transfer, for technology localization, and for the benefits of increasing the confidence levels of mineral sites in the kingdom. That is the first part. The second part, If we go to the hydrocarbon industry, one of the biggest questions that's been asked by explorationists in the hydrocarbon industry, what is the basin history? To understand the maturity of the source rock, we need to understand the thermal profiles in that basin. We need to understand the temporal changes of the heat flow of that basin. We need to understand how the strain changed over time, to understand how we link the source rock with the trap. All of that within the context of the basin analysis. However, if we speak about the mining industry, it is getting more complicated because of many reasons. One thing is that most of the basins are subjected to extensional forces. In mining industry, most of the mineral belts subjected to compressional forces. So from a tectonic point of view, it is quite a challenge to mimic the conditions that form the mineral belts that goes back in time about 700 to 600 million years ago. That is one thing. The second thing is that for the sedimentary basins, the characteristics of the sedimentary basins are very similar. If we speak about mud, speak about sand, speak about limestone, all of them not far from each other. However, if you speak about igneous rocks, the density of the rock is very different. If you speak about basalt, very different from granite, very different from other rocks. So the commodities are function of the viscosity. That's why when we speak about the forward modeling, we take into account the rheology, starting from viscous, elastic, and brittle. And we try to combine all of them together in one single equation to solve what we call the thermomechanical evolution of the mineral belt. Very similar to the mindset that being developed by our colleagues in basin modeling from hydrocarbon systems, but from mining industry. With this, we take the conservation laws, like the mass, momentum, and energy, and combine them all together in an equation that we call Stokes and Navier equation. And with that equation, we develop the model to propagate the evolution of the mineral systems in a given region. And most of these models are not local. They need to be regional. So this is one example being published in 2018 using a code that's introduced by our colleagues in ETH, the Switzerland Institute of Technology. And those models, they've been developed based on the initial and boundary conditions, based on the viscosities, based on the velocities that interpolated over time, and try to reintroduce what we have in reality as this observed in Australia, I think. And the big problem with this methodology that you have many constraints that you cannot nail it down to a precision that can allow the miners to explore their mines. However, it can give you a tool to explore a given mines that not exist in the map. It can give you a tool that can give you the conditions that you need to create a given hydrothermal deposits that may not in your account in terms of the mining exploration. So with this, if we take this into account, now we come to the work that we are doing at CACS. We think about the Arabian-Nubian Shield as one single unit that goes back in time to Neoproterozoic. The Arabian-Nubian Shield, you see it in orange, starting from the east, Al-Guwaiya, which is about 200 kilometers to the west from here, all the way to mid-Sudan. And from north, from Jordan, all the way to Tanzania. The interesting thing about this shield that formed in the Proterozoic, Neoproterozoic. Our colleagues who know the Neoproterozoic from geologists, Neoproterozoic has the same tectonic rules that exist today. In other words, we can generalize our understanding of Earth evolution today to understand the Neoproterozoic. So we don't need to invent new conditions as assumptions that not exist today. That's one thing. The second thing is that Neoproterozoic has the same conditions at that time. So all the features that have been developed, I would say, for example, for Guwaiya, or Jeddah, or Sudan, or Egypt, or Tanzania, or Kenya, I mean, all of them developed by the same conditions. So if we introduce the right boundary conditions and initial conditions for new Proterozoic Arabian-Nubian Shield, we are not exploring Arabia. We are exploring the whole region in the basis of the fundamental science, in the basis of physics. And we don't need to get all of this area resolved. However, if we take all of this into the market, it's still in the range of technology maturity about 4 to 3. It is not the way that I can come to a colleague in the mining industry and say, drill here. But at least this model can present the seed of the future development of models that can give us an insight about the work that we can develop for the benefit of the Arabian-Nubian Shield. And today, we were in the ministerial roundtable speaking about the centers of excellence, and this is one of the results of centers of excellence. As a technology and understanding doesn't really recognize national boundaries. We're speaking on behalf of Arabian-Nubian Shield, regardless who are the countries over there. We're speaking for the societies of Arabian-Nubian Shield, for the understanding of the mineral systems of the Arabian-Nubian Shield. And that is part of our work and initiatives. So, for example, if we focus, for example, on what we call Mecca-Medina Transform Zone, it is extending from the south, about south of Jeddah, all the way to the north in the black box. And that huge volcanic field, it is about 30 million years ago. Some of it about 10, some of it, it's very recent, is less than a million year. And one of the questions about this, all of this volcanic field, is what is the relationship between those volcanoes and the Red Sea, which is in the vicinity? How our understanding for the volcanoes can give us an insight about the mineralization that developed during the Cenozoic, not new Proterozoic. So we got a couple of data sets. To the left is the magnetic, to the right is the gravity. Based on those data sets, we got the geology and the constraints based on the derivatives along the Mecca-Medina transform zones. This is, by the way, will be published in January to February as a joint work. And all of that resulted in what we consider to be kinematic models or structural models for the whole Arabian or whole Mecca-Medina transform zone. With those structural models, we describe the motion. And that motion is our boundary conditions to the models. We describe the lineaments, the stress field, which is the sigma H, the horizontal maximum stress field. And all of that enable us to develop the numerical model. And with the numerical model, we extended the forces in both sides, across the central Red Sea and the volcanic region. And what you see to the right is the strain map. The strain map, the dark red colors represent the strain localizations. With those strain localizations, those are the areas of the regions where we believe can represent a localization for mineral deposits. At the same time, as we speak about as we're speaking about Cenozoic, those locations represent the geohazards for us. So when we speak about the Mecca-Medina transform zone, is a potential geohazard region because of those zones. So mining is a gift for us as we talk about long history times, but it is a challenge for us as we speak about recent times, as most of those regions possess, I'm finishing, as most of these regions possess the geohazards, high-level hazards. So, taking all of this into account, we validate our results with the LAB, the lithospheric, asthenospheric boundaries. And the big problem that we face so far for Western Arabia is a three-dimensional problem, not two-dimensional problem. So we need to develop our 3D model to understand what is Western Arabia is all about. And that's our work in collaboration with different agencies, including the ETH, the Switzerland Institute of Technology. And with this work, we try to develop a 3D model into account the thermomechanical history for the Western Arabia. This is our model that we developed so far. By the way, this is the results we got about three weeks ago, and it is under process. The model itself is a 3D model. We take into account the red, which is the thermal profiles of the whole lithosphere. At the same time, we took into account the viscosity based on different layers. And that's what I mentioned. That is the challenge from hydrocarbon industry. You don't have to account larger viscosities in hydrocarbon system. We do in the mining industry. And that's one of the challenges that we have so far. So having all of that, we introduce the boundary conditions in the top and the down and all the faces around the model and get some results. And with these results, this is the strain rate map for the boundary conditions that we developed so far. And what you see here, for example, in the yellow, represent the strain localization accommodated by the rift itself. And that is a process driven, is not actual reality. And when we try to do this, in the 3D modeling world, you tweak one of the boundary conditions in one side, and you don't expect the effect to be propagated to the other side. And that's why one of the notions in the boundary conditions or the modeling is simplification. It is unrealistic simplification. We have to do it. We know the world is not simple. It's complex. But we have to do it simple in our understanding. We know the precision that we are developing is not enough for mining companies. But we have to develop these models for first-order problems. And that's why this work is the seed of a larger understanding of the Arabian-Nubian Shield. With this, I leave you with the discussions about the importance of building knowledge across industries, including hydrocarbon and mining. I just leave you with the example of companies that made that transition. And hopefully, the transition not in terms of economic impact, but in technologies, talents, and mindsets. I leave you with a review of technologies that we developed so far for the last years and the scientific endeavor that we're leading today at KAXT for the prosperity of the super region and for the development of new niche technologies for the benefit of mining industry. Thank you very much.